Thank you for joining us with this Year 12 M1 revision. This support session is to do with pulleys and vectors. So let's have a look at the first question. Here we have a particle of mass 4 kilograms is moving up a fixed rough plane at a constant speed of 16 meters per second. So let's get a diagram here. We've got a 30-degree inclined plane. There's a mass of 4 kilograms, so we'll put 4g down. It's moving up the plane at a constant speed of 16 meters per second. So if the speed is constant, therefore acceleration will be zero. When you have a zero acceleration, it means that the forces are balanced. So the forces up the plane will equal the forces down the plane, or the forces to the left will equal to the forces to the right. There's a force of magnitude 36 newtons. Now here we have a 36 Newton force not parallel to the plane. It is at an angle of 30 degrees to the plane. The coefficient of friction between the object and the plane is nu, so that the coefficient is nu. That therefore the resistant friction will be nu times n. That is for the maximum friction force. Now if it's moving up the plane, it means that the friction is a maximum. Ever while it's moving, the friction is a maximum in the opposite direction to the movement. So we'll just make that note here. That means if it's moving up the plane, there is a maximum friction acting down. So that's F max. Part A, find the magnitude of the normal reaction between P and the plane. So we're looking for this force here, and we're going to put N. N is acting at 90 degrees to the plane. We're going to break this up into two components. We're going to have this plane here. That is, I will call up, and I will call that down. And then I will have at 90 degrees to that, parallel to the plane. Here I will call this the forces to the left and the forces to the right. All right, let's have a look at these two forces. Let's get the forces up equal the forces down. Now what are the forces acting up? Now we've got N. N is acting up, and there's another force 36 newtons. There is a component, the up component of that force. So we've got the 36 Newton component that's acting up. The forces down is simply the mass due to gravity, the 4g component acting down, and that is, we'll just sort of get this right angles across. That is this length here. That's the component of the 4g. That's the component of the 36, and that's the component for n. So let's add these up. We've got n plus 36 cos, what is that angle to the vertical? If this is 30, then the other angle will be 60. 4g cos, what is the angle to that down? And that is 30 degrees. So it would be cos of 30 degrees. Cos of 60 is a half. So let's turn these into numbers and find n. So let's get the calculator. 36 times cos of 60, and that equals 18. N plus 18. Now 4g cos 30. So let's get our calculator. 4 times g, 9.8, times cos 30, cos 30.866. So we've got 33.9, 33.948. 33.948. 4g cos 30. Let's have a look at now if we just take n and take this across, that would be 33.948 minus 18. So let's subtract 18 and we've got 15.948. 15.948. 15.948. Now that's n. We will say that's approximately 15.9 newtons. So we'll put here the magnitude of the normal is 15.9 newtons. Let's look at part B. Find the value of our coefficient of friction. Now we've done the force up equals force down, so let's do the force to the left. That's actually down the plane. The force to the left will equal the force to the right. That's actually up the plane. Will equal the force to the right. Now what are the forces acting to the left? Now we've got the friction force, which equals nu times n. We've got the force down the plane due to gravity, so it's that 4g component, and they're the only two forces acting to the left. Those two forces will equal, there's one force acting to the right, and that's the up component of our 36 newtons. So that's the 36 newtons component. Okay, let's get this into an equation. Our friction force is nu n plus our 4g component is 4g, that's 60, so cos of 60. And then our force up the plane is 36 cos 30. 36, and there's 30 degrees between the force and to the right, so that would be 36 cos 30. All right, we know n is 15.9, so our coefficient times 15.9 plus, and let's get these calculations here. So 4 times 9.8 times, what was it, cos 60. That is 19.6. Now 36 cos 30. 36 times 30 cos, that is 31.177. Just check that. 31.177, yeah. Therefore, if we took 31.177, take away 19.6, and then divide that by 15.9, so take away 19.6 and divide by 15.9, we have a coefficient which is 0.728. Let's just check that. So let's just call that approximately 0.73. So we will put nu is approximately 0.73. I would keep using 0.728 instead. In fact, we used a rounded off number here. So because if we had have used 0.948 here, we would have got a more accurate value in this position. Now, part C, find the distance that P travels between the instant when the force is removed and the instant when it comes to rest. Well, let's say the force is removed, so we don't have this force anymore. We get a completely new formula for the force up equals force down, because this component is no longer acting up. This component still acts up. This component will still act down. So we get let's go see, we get a new force up equals force down. So let's just have a look at what happens to our N. Once we remove that force, our N changes. And when our N changes, so does our friction force, because friction is calculated by multiplying U times N. So our force up N will equal the force down 4G cos 30. Therefore, our new normal, as soon as the force is taken away, our new normal becomes 33.948. That's our new normal reaction between the P and the plane when the force is removed. Therefore, our maximum friction, and ever while there's movement up the plane, and we're going to find the distance until it stops. Now it's going to keep moving until it stops. So friction maximum, there's still maximum friction in the opposite direction to that movement. Now the friction maximum will equal 0.728 or 0.73 times 33.948. So let's calculate that. 0.73 or 0.728 times 33.948. So we've got our new fraction is 24.714. And that's our 24.714. That's our new friction down the plane. Now let's come over here. What's changed? Our friction component becomes, this value changes. This value is gone. So really, and there is an acceleration now. So the forces left will not equal the forces right. In fact, there's only forces left. So let's have a look at what the forces to the left are. Because the forces to the right is 0. So the forces to the left is our maximum friction, 24.714, we've already worked that out, plus our our 4G component, our mass due to gravity acting to the left, will be still 4G cos 60. So let's get this calculation here. 4 times 9.8 times cos of 60 plus 24.714. So we have a force acting down the plane of 44.314. So if it's 44.314, 44.314, that's a negative force acting down the plane. Now force equals mass times acceleration. So we have a negative 44.3 Newton down the plane. We have a 4 kilogram mass, and we now can calculate the acceleration. Divide that by 4. Acceleration will be negative 11. Let's just call that 0.8. So let's have a look at our values that we've got. We've got an initial velocity up the plane of 16 meters per second. We've got a final velocity of 0 meters per second. We've got an acceleration of negative 11.08 meters per second squared, and we want to find how far it takes. So we can use v squared equals u squared minus 2as. So v squared is 0. 16 squared minus 2 times negative 11.08 times s. So negative 16 squared is 256 equals negative 22 equals v squared equals u squared. Is that right? V squared equals u squared plus 2as, I should say. V squared equals u squared plus 2as. That's better. And we've got negative 22.16s. Now negative 256 divided by negative 22.16 will equal about 11.55. So we'll say S equals approximately 11.55 meters. And so we will say, therefore, S is approximately 11.6 meters. So we will 11.6 meters. Okay, so we worked on the principle of forces to the left equals forces to the right. Forces up equal forces down. Let's have a look at the answers. We've got the first question asked for what is the coefficient of friction, and we've said 0.73. Oh, that was the second question, but we're correct. Okay, what was the first question? The magnitude of the normal. The magnitude of the normal, they've said 15.9 or 16 newtons. We've said 15.9 newtons, so we'll give that a tick, correct. And finally, S, our distance after the force is removed, they've said 11.6 meters or 12 meters. We've said 11.6 meters. So we've got these three parts correct. So hopefully this explanation has been of assistance. I'd like to move forward into the second question. The second question states that a boat is moving with a constant velocity of negative 4I plus 8j kilometers per hour. So let's just put V equals negative 4I plus 8j kilometers per hour. That's in I and j components. Calculate the speed. Well, the speed is if you have a position and every hour it moves to the left 4 and up 8, then the speed actually is the hypotenuse of that, and that's found by going the square root of negative 4 squared plus 8 squared equals the square root of 16 plus 64 equals square root of 80 kilometers per hour. So that is the speed, root 80 kilometers per hour. You can turn that into a decimal if you like. It's going to be approximately 9. So we will just put here root 80 kilometers per hour. Part B. When time equals 0, the boat has a position 2I minus 8j. So this is the starting point pretty much, 2I and 1, 2, 3, 4, 5, 6, 7, 8. This is the starting point at time equals 0. And the position vector at any point in time is P. Now if it's moving for every hour, so it starts and then at every hour it moves back 4 and up 8, and so that's the velocity vector. So it starts at, so P equals its starting position, which is 2I minus 8j, that's starting position. And then every hour it goes back 4 i's and up 8 j's. Well, that is P in terms of T. What we'll do is we'll just expand this. That will be negative 4Ti plus 8Tj. Now we group the I components, so 2, take 4Ti and 8T minus 8J. All right, that's the position vector of the boat. So we'll just put that here, 2 minus 4Ti plus 8T minus 8J. Now, a second boat, Q, is moving with a constant velocity. At time t, the position vector of Q is Q. Now, it's here we've got where it starts, and then they've got minus t, but if you consider that to be plus t, that would be negative 6i and negative 8j. So it starts at 1812, so that's like up here somewhere. It's way up here, actually. And it's heading left and down, so it's heading back 6 and down 8, so back 6, down 8, back 6, down 8. It's heading in this direction here. Q is heading, starts here, but it's heading left 4 and up 8, so left 4 and up 8, 2, 4, 6, 8. It's actually heading in this direction. So that's Q and that's P. Hopefully they miss each other. They should be fine. Find the value of T when P is due west of Q. So at some point there is a position where P is due west of Q. That's west. Now the characteristic of being west means that, and I'll make a note here, if P is due west of Q, then the J components, or the Y values, are equal. So they have some I component and a J component. Q has some I component and the same J component. Then they're on the same line of latitude, pretty much. So if they've got the same J components, all we have to do is equate the J component for P, which is 8T minus 8, and the J component for Q. Well, let's expand this. So we've got 18I plus 12J minus 6Ti minus 8Tj. Group these in I components, so it's 18 minus 6Ti, and it's 12 minus 8Tj. And that is the component that has to equal the P, the boat at Q. The J component will equal the J component for P. So that should equal 12 minus 8T. So let's solve this simple equation. Bring the 8 minus 8T over to be plus 8. So that's 8T plus 8T, 16T. Take the minus 8 over to be plus 8. So 12 plus 8 is 20. Therefore, T will equal 20 over 16. And if you would like, you can just turn that into, say, a decimal value, 1.25 hours. So at the 1.25 hour mark, P is due west of Q. But they didn't ask for, oh yes, find the value of T. Therefore, part C, T equals 1.25 hours. Part D, find the distance between P and Q when P is due west of Q. Well, then the distance would simply be, because they're on the same line, the distance will simply be the difference between their I components. So for part, just graphically looking at that, we used our logic and say, all right, then the distance will be the difference of the I components since P is west of Q, and that has to be when T equals 1.25. So let's look at the positions when T equals 1.25. So the position for P at T equals 1.25. Let's just have a look at the position for P. P will be at 2 minus 4 times 1.25 I and 8 times 1.25 minus 8j. So P will be at 2 minus 4 times 1.25 is 5. So 2 minus 5 is negative 3i. And 8 times 1.25, 8 times 1.25 is 10. So we've got 10 minus 8 is 2j. All right, what's the position of Q at T equals 1.25? So that would be 18 minus 6 times 1.25 I and 12 minus 8 times 1.25 j. They should be the same. 6 times 1 1/4 is 6. 6 times 1/4 is 1 1/2, so that's 7 1/2. 18 takes 7.5 is 10.5. And 8 times 1 1/4 is 8, and 8/4 is 2, so 12 minus 10 is 2j. You see they're both at 2j. We've already established that. We just didn't know exactly where that was, so we now know that's at 2. And the distance will be the difference between their I components. Therefore, the distance will be 10.25 minus negative 3 will equal 13.5 kilometres. So the distance will be 13.5 kilometres. Let's have a look at this answer. They've said that route 80 or 8.9. Okay, good. So our first speed we've said is route 80, so we're correct there. The P. Now we've got, they have not put it in terms of, they haven't expanded. So we've said 2 minus 4ti minus plus 8t minus 8. So if we just compared that with our value, they are in fact similar. We've gone, this is what they've done, and we've just converted it into look like this. Good. All right, our time will 5/4, so our time is 1.25. So we are correct, 1.25. And D is all right. They've said just subtract or get the difference, and it's 13.5. So we've got 13.5 kilometres, and we've said 13.5 kilometres. So correct. Question 2 completed. Let's have a look at question 3. A particle of mass 0.4 kilograms. So if we use this diagrams, that's 0.4 g acting down on a rough fixed plane by a horizontal force of magnitude p. Now, I'll draw this again because a push force is similar to a pull force of p newtons. So we've got 0.4 g. The force acts in the vertical plane containing the line of greatest slope of the inclined plane which passes through the particle. The plane is inclined to the horizontal with an angle alpha, where tan of alpha equals 3/4. Now, something interesting about this is when you've got tan of alpha equals opposite over adjacent is 3/4, we can use Pythagoras to help us find the hypotenuse, which is 5. Therefore, if we have to use sine of alpha, we could say opposite over hypotenuse. Or if we have to use cos of alpha, we could say adjacent over hypotenuse. So we've got all three values now. The coefficient of friction is 1/3. So this is 1/3. Therefore, our maximum friction force will be 1/3 N, or mu N. Given that the particle is on the point of sliding up the plane. This is very important because if it's on the point of sliding up the plane, it's just about ready to move. Now, if it's on the verge of moving, that is as good as moving. It is, therefore, the friction has reached a maximum in the opposite direction. Now, it wants to move up the plane. Since it is about to move up the plane, any more force it will move. Therefore, we know that maximum friction will be acting in the opposite direction, and that is down the plane, acting in the opposite direction. So we've got a maximum friction already acting down the plane. Now we've got also an N, the normal, to the plane. Find the magnitude of the normal reaction between the particle and the plane. So let's find N. Now in the earlier question I mentioned that we'll break this up into left and right, and we'll call this the up and down forces. Now to find normal, we equate the up and down. So let the forces up equal forces down. Now what are the forces acting up? There's only one force acting up, and that's the normal. Forces acting down, we've got this force, we've got the 0.4 G component, which is resolved across at 90 degrees, so it's that component. And we've got the pull or the push force, which is, I've turned it into a pull force, acting down, and that is, this is the pull force acting down component. I'll put the down component, the push force down. All right, let's make this into an equation. N is simply N. 0.4 G has to get the component, and we need that angle there. Now if that's alpha, that's alpha. So that will be cos of alpha. The push force is P. What is the angle here? If that's alpha, and we're going through the other angle, so we could say sine of alpha, or we could go cos of 90 minus alpha. Now, get this equation, N equals 0.4 G. We can work this one out because cos of alpha is 4/5. So 0.4 times G times 4/5. And this will be P times 3/5, which is sine. Get our calculator. 0.4 times 9.8 times 0.8, 4/5. 3.136. And we'll call that 0.6p. All right, that's one equation. What's the other equation? The other equation is found by the forces to the left equals the forces to the right. And we will have two equations and two unknowns which is P and N, forces to the right. So what are the forces to the left? We've got the maximum friction, we've got the 0.4G component to the left, and there's only one force to the right, and that is the P component. All right. Here we've got the maximum force, and we've worked out the friction to maximum is 1/3 N. So let's make this an equation. 1/3 N for the friction force. 0.4 G cos, what's that angle? Down the plane. It's this angle here. So if it's not going through alpha, so we will use, rather than cos, we can say sine of alpha. And this is P cos alpha because it is going through, resolving through at the angle alpha. So 1/3 N plus, let's work this one out, 0.4 times G, 9.8, times sine of alpha, which is 0.6. So 2.352. 2.352 equals cos of alpha is 0.8, so 0.8 P. Now there's our second equation. We want N, so let's replace this P. Actually, let's write them underneath each other. Now 0.6 and 0.8, if I times 6/8 of 48, 24. If I times this by 3, I'd get 2.4. If I times that by 4, I'll get 2.4. So let's multiply this whole equation by 4. We'll get 4N, 3.136. 3.136 times that by 4, 12.544. 12.544 plus 2.4 P. That's our new equation 1. Times everything by 3. So 1/3 times 3 is 1, so that's N. 2.352 times 3, 7.056 equals 2.4 P. So all I've done is I've tripled this equation, I've times that equation by 4. If I take the new equation 1 and minus the new equation 2, I'll get 4N, take away N, I get 3N. Nothing here, minus 7.056 on the left. Now on the right, we've got 12.544 and 2.4P, take 2.4P is cancelled. So we've eliminated P. This equation says that N will equal 12.544 plus 7.056 and then divide that by 3. 12.544 plus 7.056 and let's just get that answer first and then divide that answer by 3. 6.53 recurring. So N equals 6.533 newtons. So we'll put here approximately 6.53 newtons. Now we have to find the value of P. We simply need to substitute this value into either equation 1 or equation 2. So let's just put it in equation 2. And sub N equals 6.533. So we've got into equation 2. So 6.533 plus 7.056 equals 2.4P. Therefore, P will equal 6.533 plus 7.056. Divide that by 2.4. So get the calculator going here. We had it. Plus 7.056 equals, divide that by 2.4, and we've got 5.66. So let's just P equals 5.66 newtons. So we've got our p-value of about 5.66 newtons. All right, so let's have a look at what our solutions say. N is about 6.53 or 6.5, and we've said N is 6.53, so we'll tick that. And force P is 5.66 or 5.7, and we've said 5.66. Good. So there we have the three solutions to the three questions. I hope that this has helped. All the best in your exam, and until I see you or talk to you next, stay happy.